Hello, welcome. In this video I will explain the basics of fire and seismic resistance of wood. First, I will talk about fire resistance. Mass timber does not ignite easily. The outer layer will char. This forms a protective layer that shields the inner layers of a mass timber component from the heat of a fire. Burned timber surfaces had a surprising advantage in the outdoors. In Japan, the method of charring boards called Shusugiban has been used for centuries to improve the weather resistance of timber facades. In a fire, the layers behind the charred layer retain their constructive capacity completely. The inner temperature of the burning mass timber component remains at a moderate temperature. Mass timber construction systems are very predictable in instances of fire. The burn-in speed of softwood is 0.7 millimeters per minute. So by oversizing a structural beam or floor, a fire resistance of up to 120 minutes can be realized. In this fire test, various insulation materials were tested. The flame of each burner reached a temperature of over 1,000 degrees on the materials in the mock-up, being a plasterboard underneath the respective 10 centimeter thick insulation materials. From left to right, cellulose, styrofoam, glass wool and rock wool. For the styrofoam, the burn-through took just 9.2 minutes. There was dripping of molten plastic and toxic fumes. With the glass wool, after a total of 12 minutes, the flames pushed through upwards. With rock wool, the burn-through took 18 minutes. Amazingly, after only 25 minutes, you can still touch the cellulose surface without burning your hand, even though the cellulose is hit from below with an open flame of over 1,000 degrees. The flames apparently cannot harm the cellulose material that much. The cellulose actually didn't really burn. It gave way only after 32 minutes. It took the flames twice as long as with the rock wool and more than 3 times as long as with the styrofoam. It is almost unbelievable that the cellulose insulation material, which is fundamentally made of wood, can resist the flames that long. Before finalizing the design of the structural parts for the timber tower Mjøstarnet in Norway, real-life fire tests were performed. The rectangular timber columns were subjected to flames coming from all sides in this laboratory furnace. This is what they looked like after the test. Notice that the burned columns ended up in a rounded tree trunk shape. Because of this extensive fire testing, the engineers were able to optimize the structural timber columns and beams that were then produced for the building. Have you ever considered how well timber construction stands up to natural disasters? Let's look at a case study in Uttarkashi district in India, where timber structures have withstood earthquakes for almost 900 years. This is a Koti Banal, a 5-story house built in a region prone to earthquakes. It has a stacked timber log structure, infilled with earth and stone. Here is a diagram showcasing the horizontal load capacity of Koti Banal buildings, which enables its seismic capacities. It's a visual testimony to the resilience of traditional log construction methods, underscoring their relevance even today. Mass timber buildings are light and flexible, and are therefore less likely to collapse and take damage in case of an earthquake. Any damage that does occur is often easily repairable. The mass timber panel construction proves to be very suitable for mid- and high-rise buildings. Here you can see seismic testing on a 1:1 scale, mass timber building done on a large shaking table in Ivalsa, Italy. In this test on a 10-story structure in San Diego, different mass timber products for floors and walls were tested to compare their performances. The east-west rocking walls are made of CLT, and the north-south rocking walls are made of mass plywood, which is in fact a giant LVL plate, only recently developed in Portland, Oregon. Floors 1 to 2 are made of CLT, floors 3 to 4 are made of glulam, floors 5 to 6 are made of NLT-DLT, and floors 7 to 10, columns and beams, are made of LVL. Here you see the 1:1 scale mock-up on the shaking table in San Diego, where the different mass timber products were tested together with fully mounted facades. It is amazing to see the variety in mass timber products that are already available to make earthquake-proof high-rise buildings,